Good afternoon, everyone. Happy Friday. Welcome to TVE Happy Math Hour, our weekly interactive math reviews for Math 1314 and Math 1324, presented by Yvette Chuca, Ruben Carizales, and Albert Isasi. Our session will be starting soon. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. Thank you. So now, at this time, please mute your mics for the best sound experience, otherwise the feedback could interfere with information we will be sharing. We'll be sending the 1324 room link on the chat so that you may connect to your session if you're here for Math 1324. Ms. Patricia will be sending individual messages to everyone to gather your student ID numbers to sign you in. Without further ado, I'll pass it on to our presenters so that we may begin.
Hello, everyone. Welcome back to a summer session. And as they stated right now, we do have two courses that we're doing presentations for. And so if you are enrolled in Math 1324, go ahead and follow the link. And then also we will be asking each person that is in our session to provide a student ID number. Somebody from our staff is going to send you a message and just provide that student ID number. And the reason we are doing that is to help keep attendance. Some of you are going to be getting credit from your instructors. And so that is the way that we're going to be able to provide that for your instructor as well. But today here in Math 1314, my name is Yvette Chuca and I teach Math 1314. And so today we're going to go ahead and cover as many of these slides as we can. Our goal is to provide you with examples of um, the material that you are looking at right now in your classes. And so first we're going to be just talking about Webassign really quick. Hopefully all of you have signed up for Webassign already. If you haven't, you want to try to do that as soon as possible because most of your instructors are going to be using this for your homework or exams. So to sign up for Webassign, you would click on the enter class key. And then there's two ways that you can sign up for Webassign, and it really depends on how your instructor has the course set up. So some of you, your instructor is going to provide this class key for you. So you're going to be needing this class key. But for some of you, your instructor set it up through Blackboard, and so you're not going to get a class key, but you would just click on the link that looks something like this. Of course, it's going to have a different CRN for you if you're not in my class, for example. Okay, so once you're in Webassign, you're going to click on register and access code, and you could either buy it by clicking up here where it says enter access code. But if you buy a new textbook at our bookstore, then it's going to include the access code. If you are purchasing a book from somewhere else, just make sure that it does include an access code because without the access code, you won't be able to complete your homework assignments. Okay, so there's two choices when you're buying this access code. One is called Cengage Unlimited, and the other one is says Homework and Ebook. So the Homework and Ebook is about $100, and the other one is 119. The big difference here is that if you're taking another class that uses a Cengage product, then it's going to include both books. Okay, so if you are taking, for example, a computer science class and your instructor's book is a Cengage product, then this might be a better option for you. Okay, so just check with your instructors. So if you don't have the access code and you are not going to purchase it right there and then, they do give you free trial that runs for about 7 to 14 days. So you would just click on open course and use the free trial. Okay, so at any time you can click on your courses here will list your courses. And at any time you can purchase the access code by clicking on this button here. Okay, so once you're enrolled in the Webassign, you can change your password by clicking on your name. You can go ahead and look at the rental options if you prefer to have a hard copy book. Okay, once you're in Webassign again, it's going to keep reminding you how many free days you have left. If you prefer to have instructions in Spanish, then if you click this little globe thing, you would be able to change your instructions to another language. So this is an example for Spanish. And I'm going to go over some of these tools that you have here. The little envelope here will allow you to enter an email, and then you can highlight notifications. So this is really nice because if your instructor changes a due date, it's going to let you know through your email, or it's also going to remind you if you have due dates. And so this might be a nice way to always know what is going on with your Webassign, if there was an announcement posted, or if your teacher has replied to one of your messages. Your ebooks, your product here includes an ebook, so you can click on it and it's going to open up an ebook. The communication center is a place where you can send emails to your instructor. And then of course, under grades, you'll see your grade here. Sometimes your instructor doesn't have it set up. And so if you can't see your grade, then that's the reason is your instructor hasn't set it up. And then of course, under your assignments, it's going to list all of your assignments. And then you do have some other options here. The class insights is a place where you can click on, and it's going to kind of give you ideas on where you need more help. And then we have on the right side at the very bottom of the left side of your Webassign course, if you click on resources, you're gonna see some resources, and these are available if your instructor made them available. So if you don't see anything here, then more than likely your instructor hasn't activated them. Okay, so you can ask your instructor if they can activate them. Usually these are like PowerPoints or videos. Then you also have a personal study plan. This again is also available if your instructor made it available. But this is just a nice little place where you can, for example, click on 1.1, take a practice quiz, and then it gives you a tutorial. So this is not for a grade, it's just for your own practice. In your homeworks, when you have them listed here, you're going to see some of these icons. Okay, so for example, this icon here tells you that the assignment has a password. Then you have that you have a timer on it. You have 50 minutes remaining. And then some of them is going to tell you that you need to complete a different assignment before you can open the one that you want to work. The lockdown browser, if you see this symbol, make sure that you try to install this lockdown browser before you try to take your exam before the due date. So like if you know you have a test on next Friday, then try to download this before then, because sometimes students have a lot of issues with the lockdown browser. Okay, so when you have your assignment open, you're going to see these buttons here. The Ask Your Instructor button is really nice because if you click on that, if you don't understand a certain question, it's going to take a picture of this question and it's going to send it to your instructor, notifying them that you have a question regarding this question here. Some of the questions have a read it button that takes you to the ebook, and some are going to have a watch it button. If you miss an assignment, you might have the opportunity to request an extension. Of course, this is only available if your instructor has activated it. Okay, so that was a really quick overview of Webassign. But for this week, chapter 1 is going to be most of, if you're taking a 5-week class, then basically all of chapter 1 is due this week. If you're taking a 10-week class, then you have sections 1.1 through 1.4 that will be due this week. And so I'm going to go over a couple of examples for you, and I will go a little bit slower on these examples. So the big part of chapter 1 is to graph equations, and we're going to be covering these two methods, point plotting method and the X and Y intercept. The third option is also going to be available in section 1.6, and this is like a nice little way to graph as well. So here we have the point plotting method. So basically the idea is we are going to draw a table here, and we're going to have an X, a Y, and then what we call an ordered pair. And so the idea here is that we can pick any value we want for X. The only values that we do encourage you to choose is to always make sure to include 0, some positive numbers, and some negative numbers. So we call this your input or your independent variable. And so what we're going to do is our goal is to figure out what y is. So if x is a -2, wherever you see an x, you're going to replace it with a -2. So in this example, we have y equals -2 times -2 plus 5. So -2 times -2 is 4 plus 5 is 9. So we get y is equal to 9. So we keep doing this for every point. Here your order pair is going to be your x value is -2, and then your y value is 9. So we go to -1, and I plug it in, then we get 7. So our order pair here is going to be -1 and 7. If we plug in 0, then we get -2 times 0 plus 5. So -2 times 0 is 0, plus 5 is going to be equal to 5. So my ordered pair is going to be 0, 5. And then we have our 1 and our 2. So we would work it out the same way, giving us our points here. So here we plug in 1, we get -2 plus 5 is 3. So here should be a 1, and this should be a 2. So I forgot to change the zeros, okay? So this is a 1, and this is a 2. Now, if you know that the graph that you're going to graph is a line, then you really just need 2 points. And so part of the goal for this semester is you'll be able to recognize by looking at an equation if you're going to be graphing a line, a circle, or anything else. Okay, once you have your ordered pairs, then we can plot those. So to plot these, we go our x value, in this case is -2, and then our y value is 9, so we would plot our point here. So these are all of our points. And then so we would draw our line. So make sure that in Webassign, when you're doing this, read the instructions correctly, because some questions we're going to say plot the ordered pairs, and this is what your graph should look like. But if it says to graph the equation, then you need to include the line here. Okay. So let's try another example. And just really quick, you want to always pick the line that has the 2 arrows, because this is going to extend forever. So here, this is no longer a line. And again, as I mentioned, you'll be able to determine if this is a line or if it's a parabola as you go through the sections. Okay. So if we pick some points and I plug in the -2, then we have y is equal to 5 minus -2 squared. So -2 squared is 4. And so we end up with 5 minus 4 is equal to 1. And so my order pair is -2 and 1. Okay. So I'm going to go ahead and switch to another room really quick. So go ahead and try -1 and 0. And then in about 30 seconds, I'll be right back. Okay, so hopefully you got to try the next 2 examples. I just needed to change rooms because some of my family came in. All right, so if we plug in -1, then -1 squared is going to become a +1. So we end up with 5 minus 1 is equal to 4, and our order pair is -1 and 4. And then we plug in our 0. So y is equal to 5 minus 0 squared. The 0 squared is 0, so we end up with 5. And then for 1, we end up with 5 minus 1, which is equal to 4. And then for our 2, we end up with 5 minus 2. 2 squared is 4. So we end up with 1. So if we plot these points, they're going to look something like this. So if we draw our curve, then we end up with a parabola. And so the beauty of mathematics is that right now you're learning just different tools, and then you'll be able to use the tools that you feel more comfortable with. And so point plotting is just one way to graph, and then you'll learn different ways of graphing. So here, I have a video. I'm not going to play it, but I just wanted to put the link here, and I'll put it in the chat in a little bit. But in Webassign, this is just a quick short video that I made for my class where it shows you how to use the actual graphing tool on Webassign. And so in a little bit, I'll go ahead and post the link for you. That way, if you get a chance, you can look at the video if you're stuck with the Webassign. So another method we can use is the X and Y-intercept method. And so for this method works great if you have a line. And so here, the X-intercept is where the graph crosses the Y-axis. And then the Y-intercept is where the graph is going to cross this Y-axis. But we want to notice something special about this is that in this point here, the value of the Y is always going to be 0 whenever you have your X-intercept. And the value of the X here for your Y-intercept is always going to be 0. And with that information, we can find the X-intercept and the Y-intercept if we don't have the graph. Okay, so to find the X-intercept, always let Y equals 0 and then solve for X. And then to find the Y-intercept, we let X equal 0 and then we solve for Y. So let me give you an example here. So here is my equation, Y equals negative 2X plus 5. And I'm trying to find the X-intercept. So I'm going to let Y equal 0. And then I'm going to solve for X. So I'm going to subtract 5 on both sides. And so I end up with negative 5 is equal to negative 2X. And then I'm going to divide by negative 2. So we end up with 5 halves is equal to X. So we end up with 5 halves, and our X-intercept is going to be 5 halves and 0. Now for the Y-intercept, we're going to let Y equal 0. So anywhere you see, we're going to let X equal 0. So anywhere you see an X, we're going to replace it with 0. Negative 2 times 0 is 0, plus 5 is going to be 5. So now that we have our 2 points, we can plot them. And so here's my first point and my second point. And then we can draw the line. So just really quick, so notice here, this is 5 halves. We know that's 2.5. And so if you try to guess on the Webassign app, it might count it wrong if you don't put it quite at 2.5. So the good thing though is once you plot it close to it, on the right side of the screen, it's going to open up your point, and then right there you can put 2.5 so that it can give it the accurate location. Okay, and you'll see that in the video if you look at the video. So then we can draw our line here. Okay, so that is using the X and Y intercept to graph a line. So in section 1.2/1.3, it's going to be talking about writing equations of a line, the slope, and so let me just give you some quick ways that we can write a line. So this first way, this is called the general form, ax plus by equals c. And then we have something called the point slope form, y minus y1 equals m times x minus x1. And then we have the y-intercept form, y equals mx plus b. I personally like to work more with y equals mx plus b, but you can use any of these forms here. So if you have an equation set up as y equals mx plus b, the m is going to represent the slope, and then the b is going to represent your y-intercept. However, it has to be in the y-intercept form. Okay. Now, if you know the slope and you know the y-intercept, then you can always write your equation. So for example, if you have this question here, write the equation of a line with slope 4 and y-intercept 5, then you can start off by writing your slope-intercept form, which is y equals mx plus b. They tell me that the slope is 4, so that's going to be your m. And then they tell us that the y-intercept is 5, so that's going to be your b. So all we have to do is plug it in to this equation. So we would have y is equal to 4x plus 5, and that would be our answer. Okay. Of course, it's not always this straightforward, right? So we'll look at some other examples. So here it says write the equation of a line. So that should be your keywords here. Write the equation of a line with slope -2 and passes through the point 0, -4. So as soon as you hear the words write the equation of a line, you want to ask yourselves, basically, if you have two things. Number one is, do you have a slope? And then number two, do you have a point? So here we do have a slope, and here we have at least 1 point. So do we know the slope? Yes. Do we know the intercept? We actually do also know the x-intercept. So here we have m is equal to -2. That's our slope. And then our y-intercept is going to be 0 and -4. I know that this is my y-intercept because the x is equal to 0. That tells me that that's my y-intercept. And so I have my slope-intercept form. So I'm just plug in these numbers. So m is -2 and my y-intercept is -4. And so that would be my equation. Okay. So let's look at a different example. So this example kind of looks like this one, but a little bit different. And so here, write the equation of a line that passes through the points 1, -3, and 0, 4. So again, the two things you should ask yourself is, do you have a slope? Do you know the y-intercept? So in this situation, they don't straight out say, this is your slope, but they give us enough information to find the slope. Okay. So to find the slope, you're going to be using this equation here. And we have m is equal to y2 minus y1 divided by x2 minus x1. So here are points. We can label them. And let me get my pen out really quick. Oh, here, I labeled them here already. So this point here, I'm going to call this x1, and I'm going to call this one y1. And then the second point, I'm going to call it x2 and y2. So you might be asking yourself, well, how do I know which is x1, y1, and how do I know which is x2, y2? It doesn't matter. You could have called this point x2, y2, and this one x1, y1. Okay, so you can flip it back and forth. The only thing you cannot do is call this x1, y2. Okay, so in our formula, it's asking for y2. We called that 4. And then y1 is our -3. So we have 4 minus -3. x2 is 0. And x1 is 1. So negative, negative is a positive. So 4 plus 3 is 7. And then 0 minus 1 is -1. So my slope is going to be a -7. Okay. Now for our y-intercept, here we have this point here. We know this is not a y-intercept because we don't have the x as 0. But the second point, 0, 4, since x is 0, that's going to make that my y-intercept. So this is my y-intercept. So now I know my slope and I know my y-intercept. My slope is -7 and my y-intercept is 4. So this is going to be our equation. Okay. So let's look at another one. So this looks like the other one. It's just a little bit different. So first we need to find the slope. So we have y2 is 4, y1 is 0. So we get 4 minus 0. So there's a mistake here, right? So let me take my pen out. Give me a second. Okay, so we're going to have here y2 is 4 minus y1, which is 0, divided by x2, which is -1, minus my x1, which is 2. So 4 minus 0 is 4, and -1 minus 2 is -3. Okay, so this is incorrect. Okay, so do we know our y-intercept here? Do you all think that 2 zeros are y-intercept, or is that not the y-intercept? So if you look at this, since our x is not 0, then this point here is not our y-intercept. In fact, it's going to be our x-intercept. But in order to do this, we need this to be our y-intercept. So what's going to happen is we're going to have to do a little bit more work than the other few examples. Okay, so let's remember our negative 4/3 for the next slide. Okay, so let me go to the next slide. All right, so here we said that the y-intercept is not 2, 0, and so we actually need to find the y-intercept. And so one way to find the y-intercept is going to be to use the point slope form here. Or you can use the y equals mx plus b. It's either way is going to be fine. So let's go ahead and try one of these. So we're going to choose any point. So you can either pick this one or you can pick this one. It doesn't matter. I'm going to choose the 2, 0. And then we're going to plug in the information we know. And so here I'm going to need to readjust here a little bit since our slope was incorrect. So let me go ahead and, so I'm going to have here y minus y1 is equal to m x minus x1. So we're going to substitute what we do know. Since I picked this point here, I can call the x, I can call it the 2, and my y is going to be 0. So for y1, I'm going to have 0 is equal to our slope. Remember, we got negative 4/3. And then we have x minus x1 is going to be our 0. I'm sorry, our 2. Let me erase that. Okay, so if we simplify here, then we're going to end up with y minus 0 is equal to, let's distribute the negative 4 and the negative 4/3 inside of parentheses. So we get negative 4/3 x. And negative is going to be a positive. And negative 4/3 times 2 is going to be 8/3. Okay. And then since I have 0 here, if I add 0 on both sides, then I'm going to be left with y is equal to negative 4/3 x plus 8/3, because 8/3 plus 0 is just going to be 8/3. And so that would be our equation. Okay, so let me go to the next slide. So this is just using the second method here. So if you wanted to use the second method, then let me go ahead and do it here with the pencil really quick. So the second method is using this right here, the slope-intercept form. So we have y is equal to mx plus b. And so we're still going to use this as our x and our y. So my y is 0. Remember that our slope was negative 4/3. And then our x is 2 plus b. Okay, so if I multiply this or simplify, we get 0 is equal to negative 8/3 plus b. And I'm solving for b here, so b is going to be equal to positive 8/3, because I'm going to go ahead and move this to this side. And so we would get 8/3. So to finish this up, we would have y is equal to our slope, negative 4/3 x. And then you solve for your b, so that's going to be plus 8/3. And so you can see we get the same answer. Okay, so let's go to the next example. And let me just go to the, okay, here we go. So write the equation of a line that is parallel to the line y equals negative 2x plus 4. So here, one of your keywords is parallel. If you see the words parallel, then that means that your lines are going to be parallel. They're never going to touch. And if that happens, then we say that they have the same slope. And so that's going to be very important, is that they have the same slope. Okay, so with that information, then we can try to get our answer here. So let me just keep going here. So here's the line. This line right here is the equation that we see here. So this equation is represented by this line that is graphed. And then you have your 0.34. So what we're essentially going to do is find the equation of this blue line that I'm drawing. Okay, but we're going to use the black line to figure out what our slope is. Okay, so for this black line, we have that the slope is going to be -2. And how do I know that? It's because the slope is the number in front of the x if you have it in slope-intercept form, which we do. And so for our red line that I have here now, we want to find the equation, and all we know is that the lines are parallel. So that means that we're going to use the same slope. Okay, so we're going to use m equals -2 as well. And so I'm going to take all of this information. And so here's my slope and here's my point. And then we can use either of the two forms of the line. And so I'm going to use the first one here. So we have y minus y1 is equal to mx minus x1. So that's your point slope formula. And then so we have our point -3, 4. So our y1 here, we can call it 4. So we're going to have y minus 4 is equal to our slope -2. And then we have x minus x1, which is -3. So if we simplify, negative is +3. And we're going to distribute the -2 into the parentheses. So we end up with y minus 4 is equal to -2x. -2 times 3 is -6. And then we're going to add 4 on both sides. So if I add 4 on both sides, I get y is equal to -2x minus 6 plus 4. And if we simplify, then we end up with y equals -2x minus 2. Okay, so since the lines were parallel, the important thing here is to know that we were using the same slope since the lines are parallel. Okay, so now for this example, it looks exactly the same as the other, but with one word change. So instead of parallel, it's asking for a line that is perpendicular. So this is a perpendicular line. And so a perpendicular line is going to look something like, so perpendicular lines, they cross at right angles. Okay, so what's going to happen is for our graph, we're going to have a line that is coming up here, and it's going to cross this black line, but it's going to form a right angle. Okay, if that's the case, then the perpendicular lines have negative reciprocals of each other for the slopes. Okay, so let's talk about what that means here. So for our slope that we're going to be using, we know that this line here that is given, the slope is -2. So the reciprocal of a number, a negative reciprocal for this would be that we have the reciprocal of 2, which is 1/2. And so the negative of a negative number is going to make it positive. So you get the 2, you get the fraction, you flip it over. So if you had, for example, so before we move on, let me show you this one. What if our slope was 1/3? Let's say we had 1/3. Then the negative reciprocal for this one would be the negative, and then the reciprocal of 1/3 is 3/1. So that would be a -3. Okay. So in this situation, they give us that the slope is -2. So the negative reciprocal is the negative. The reciprocal of -2 is -1/2, because remember 2 has a 1 below it. And then negative negative makes it a positive 1/2. And so that's how we ended up with the 1/2. So you know that the slope is 1/2 right here, and then you have your point. So again, we can use either method. So this time we can use this method again. So we have y minus our y1 is 4 is equal to 1/2 x minus -3. Negative negative is a positive 3. And then we're going to distribute the 1/2 into the parentheses. So if we have 1/2 times x is 1/2 x, 1/2 times 3 is 3/2. Then we're going to add the 4 on both sides. So we have y equals 1/2 x plus 3/2 plus 4. In order to add the 3/2 and the 4, we're going to need a common denominator. So this 4, we can have a common denominator of 2. And so let me go ahead and make this one a little bit bigger. So if we have 4, remember it has a 1. So if you wanted to have a denominator of 2, we can multiply by 2/2 because that's just 1. So we end up with 8/2. So in other words, 8 divided by 2 is just 4. And so I put here 8/2. So now I can add 3/2 plus 8/2 since they have the same denominator. And that comes out to 11/2. So my equation is y equals 1/2 x plus 11/2. Okay, so that is writing the equations of a line. And so again, the important thing is knowing that you need to have a slope and another point. Okay, so another topic that you're going to be seeing is evaluating functions. And so instead of y equals x squared minus 2, you might see the symbol f of x equals x squared minus 2. Well, y and f of x are the same thing. It's just kind of like a nickname to let us know that instead of an equation, we're now working with a function. Okay, so whenever you see f parentheses x, we read it as f of x. And so how do we work with that? So consider this function here. What does f of -3 mean? And so what it means here is we are basically going to replace anywhere in the function. If you see an x, you're going to replace it with the -3. And so here I would have f of -3 is equal to -3 squared plus 2. So -3 squared, it comes out to 9. And then 9 plus 2 is going to be 11. And so what this means is that when x is -3, your y value is 11. And so that's how you would graph this. So this is your x value, that's your input, and then your output is going to be your y value. So let's say I have this function, the square root of 3x minus 2, and we want to evaluate the function at x equals 2. So at x equals 2, what this means is wherever you see an x, we're replacing it with a 2. So we would end up with the square root of 3 times 2 minus 2. 3 times 2 is 6, minus 2 is 4, and so we end up with 2. If we have x is equal to a, then we're going to replace the x with a. So we end up with 3 times a minus 2. And 3 times a is just 3a. And so we can't combine this any further. So my answer would just be the square root of 3a minus 2. For letter C, we have 6 plus h. So we're going to take all of that and replace the x. So wherever you see an x, we're going to replace it with 6 plus h. So 3 times 6 is 18. 3 times h is 3h. So we end up with 18 plus 3h minus 2. Gather your like terms. 18 minus 2 is 16 plus 3h. There's nothing more I can do with that. Okay, so in this section, we're also going to be looking at evaluating a function if you have a graph. And so before we do that, just so that we can recognize these, if you notice here, you have a circle here that's not shaded. We call that an open circle. And then here we have a solid circle that is shaded. And so if it's open like this, what that means is that this number is not included in the graph. So whatever this number is, which is -2 and 5, that point is not included. So you might be wondering, well, why do we have it there? Well, the reason is there's an infinite amount of numbers that are close to 5, and there's an infinite amount of numbers close to -2. And so we want to get as close as possible. We just don't want to include that point. And so to help us with that, we put an open circle. And so that covers all these little infinite numbers that we can't really see here. Okay, so if we have a is equal to f minus 1, we're going to be evaluating that. And so before we do that, let's talk about domain. What is domain? Domain is all the x values that are being used to graph this equation. So for example, if I pick this x value here, did I use this to graph my graph? So if I go up or if I go down, I'm not going to touch the graph at all. So this value for x is not included in the domain. If we look at -5, if you go up or if you go down, you're never going to touch the graph. So that's not part of your domain. So the first value is that we can use for x is going to be from this point. And then if I pick 0, if I go up or down, I am going to touch the graph. So all of these numbers, let me go ahead and highlight them here for you. So from here, all these x's are being used, and so we say those are part of your domain. Okay, and then for the y values, that's going to be part of the range. So you want to see, where do we start using these y values? So all of these numbers here, if we go across, it's going to touch your graph. So they're going to be part of your range. Okay, so the way we write our domain is we're saying we're going from -2, which is right here. And notice that since it's an open circle, we use a parentheses because the parentheses represents that that point is not included. So we go from -2 all the way to +2. And at +2, the circle is shaded. That means that the point is included. And so in interval notation, we use a bracket for that. Okay, so our range, remember our range started with this number here, which is -4, all the way up until we get to 5. And then notice that we use brackets for both because at -4, it's part of the graph. And at +5, this is part of the graph here. Although this one is not, on this side it is, so we include it as a bracket. Okay, so how do we evaluate this function? F of -1, remember whatever is in the parentheses represents your x value. So what you're going to do here is you locate -1, which is right here, and you want to go up or down until you touch the graph. So here it's going to touch the graph here, and then you ask yourself, well, what value is that? And so that value comes out to -4. Okay, so f of 0, what do you think f of 0 is going to be? So I'll give you like 10 seconds to try to see what answer you would put there. Okay, so so here's your 0. So I always like to find the 0, which is here. Excuse me. And then I always ask myself to go up or down and then see where it touches my graph. So if I go down, oops, then it's going to touch at that point. And what point is that? So hopefully you thought of the answer that it's about to come out. So that point here is -3. What about f of 1? What do you think that's going to be? So here's your 1. Okay, so if you go down, then you can see that we're going to end up at -4. And then the last one, f of 2, is going to give us what value? So anytime, whenever I do ask questions like that, you can just throw them in the chat if you want to. But f of 2 is going to be 5. Okay, so here's 5. All right, so one of the other things that you're going to be asked to do in 1.5, I believe it is to add or subtract these functions. Okay, so notice here f of x is 3x minus 7, g of x is 4 minus x. And so we want to add f plus g of x. The first thing you want to do is kind of rewrite it. So I like to rewrite it as f of x plus g of x. Then we're going to substitute the information that we have. So f of x, they tell me, is 3x minus 7. So I'm just going to write it down here. And g of x is 4 minus x. So then we can just simplify, gather our like terms. 3x minus x is 2x. Negative 7 plus 4 is negative 3. So my answer for f plus g of x is 2x minus 3. For subtracting, we do the same thing. We can write this the way it's defined. So this would be f of x minus g of x. Substitute the information that we know. So again, f of x is 3x minus 7, and g of x is 4 minus x. So here I need to distribute the negative into the parentheses. And so I'm going to negative 4, negative negative is positive x. Gather our like terms. So 3x plus x is 4x. Negative 7 plus negative 4 is negative 11. If we're multiplying, so we have f of x times g of x. So we have 3x minus 7 times 4 minus x. So we distribute 3x times 4 and 3x times negative x, and negative 7 times 4 and negative 7 times x. So 3x times 4 is 12x. 3x times negative x is negative 3x squared. Negative 7 times 4 is negative 28. And negative 7 times negative x is a positive 7x. So we're going to combine our like terms. So here we get, I always like to write down the highest power first. So negative 3x squared. 12x plus 7x is 19x minus 28. And then the last one is our quotient here. So we're just dividing f of x divided by g of x. And so if we write down the information that we have 3x minus 7 and g of x is 4 minus x. Here we can't simplify any further, so this is going to be your answer. They're also going to ask you to find the domain of f and g, or the domain of the quotient. So when you're finding the domain, then you can ask yourself, I'll give you some pointers here. Whenever you find the domain of an equation like this, you want to ask yourself, do I have any fractions where the denominator has a variable? If you do, then automatically that's going to tell you that there's some numbers that you have to exclude from your domain. Okay, so that's one thing you can look for. The other times that we're going to have to exclude something is if you have a square root. If you have a square root of with a variable inside as a radicand, then you're also going to have some exclusions. So like if you had the square root of x plus 4, then as soon as you see that square root, that means that some numbers for x will not be included in the domain. And then the third option is if you end up with a log, like a log of, let me just write it here. Like if you have log of x plus 4 or something like this, then that's also going to have numbers excluded. You don't have to worry about the logs till you get to chapter 3, but I just wanted to mention it right now. So like here we have a fraction, we have a exponent, a variable in the denominator. So to find that exclusion, to find that number that we cannot use, you take your denominator and you set it equal to 0. So 4 minus x is equal to 0. And if I take the x to the right side, if I add x on both sides, we get 4 is equal to x. So what this means is, for the domain, you could use any number you want except for 4. And the reason you cannot use 4 is because if you were going to evaluate this at x equals 4, then notice what you would end up with. If you let x equals 4, then what does this give me? That gives me a 0 down here. And we cannot have a 0 in our denominator. It's undefined. So how do we write our domain? Well, we know that we can use any number we want except for, so here we have this here. And let me just write down some numbers really quick. So in our domain, we said we can use everything all the way over here except for this number. We cannot use 4. And then we can use all these numbers. So we represent that using interval notation. So we say negative infinity, which is all of these numbers here. And then this should have a comma. Okay. So there's negative infinity, comma, all the way to the number 4. But notice I have a parenthesis because we don't want to include 4. And then we use this symbol, which is just a U. And then we start with 4 all the way to infinity. So the important thing here is the parentheses because we're not including 4. If you are going to include a number, then you would use a bracket. Okay, so let's try another one that has a square root. Okay, so with this square root here, if we were trying to add these, we would have f of x plus g of x. So we end up with x squared plus 3 plus the square root of 2 minus x. If we simplify, we end up with x squared plus 2 minus x plus 3. We cannot combine this any further. And then for f minus g of x, we do the same thing. X squared plus 3 minus the square root of 2 minus x. So our simplification here would be x squared plus 3 minus square root of 2 minus x. I cannot gather any like terms. And then the next one here is multiplication. If we multiply these two together, then we end up with, you can leave it like this or you can multiply it out. X squared times this and then 3 times this. But I'm going to go ahead and leave it like this here. Now if you divide, then you have x squared plus 3, and then you have the square root of 2 minus x. Okay, so if you want to find the domain for this, then let's ask ourselves the questions, right? You have a fraction, so that's one thing, there's a fraction, and then you have a square root, and inside of the square root you have your x value. So we are going to have some exclusions, numbers to exclude. So for the fraction here, we have to put the denominator equal to 0. So we have the square root of 2 minus x is equal to 0. So if we solve for x, if I square both sides, then the square root and the square are going to become 1 or they cancel. So we end up with 2 minus x is equal to 0. If I solve for x, then I end up with 2 is equal to x. So what this is telling me is I cannot use x equals 2 because if I put 2 here, I end up with 2 minus 2 is 0, and I cannot have a 0 in the denominator. Okay. The other thing we have to worry about is the square root. So to find the square root or to deal with the square root, you take the radicand, which is 2 minus x. The radicand is the stuff inside of the square root. And you set it equal to greater than or equal to 0. So here we have 2 minus x is greater than or equal to 0. I'm going to add x on both sides. Okay, so I have 2 is greater than or equal to x. And so here, if I flip this around, then we have x is less than or equal to 2. So for the square root, they're telling us you can use any number that is less than or equal to 2. And then for the fraction, they're saying you can use whatever you want except for x is equal to 2. So your domain is all real numbers except for x equals 2, and then anything that is greater than 2. Okay, so if we want to put this in interval notation, then we would have negative infinity to 2. So let me just explain this a little bit more clear um, for the domain part. So whenever you have this, the answer that you get here, this is your domain. Okay, so this is telling you these are the numbers that we're going to use for the domain. Whenever you have a fraction, the number you get when you solve for x, that's the number that you cannot use for your domain. Okay, so if you had a number line here, for the square root, here's my 2. They're saying you can use anything you want that is on this side. Okay, and then for the fraction, they're saying except you cannot use this number. So when we write the interval notation, we are using everything here, so that's negative infinity, all the way to the number 2, but we put a parenthesis because we're not including the 2. So why couldn't I use, for example, let's say 4, okay? Well, if you use 4 for x, then you end up with a negative inside of the parentheses. I mean, inside the square root. So you cannot have a negative for the square root, okay? Because it's going to be a complex number. It's an imaginary solution. So we cannot use that. Okay, so that is why we're only going to the left. Okay, so for the rest of these slides, there's still quite a bit, right? So we still have to do the compositions. But if I click through them really quick, I just want to show you something. That's all we had left is just like 3 examples of the composition. But it's step by step. So what I'm going to do here is, since we only have about 2 minutes, I'm going to put my email in the chat for you. And if you want these slides for these last 3 or 4 examples, then send me an email and I will email you the PowerPoint. And then also let me put in the chat that link to that video for the graphing on Webassign. That way, if you want to look at it, it's going to help a lot. And then in that, once you click on that video link for the Webassign, then I have a whole bunch of examples in there. I have a section video for each. I have a video for each section with worked out examples. And then also I have videos that are from the homework. So whenever my students have a question on one of their homework problems from Webassign,
What's it like to learn math on Brilliant?
for some of those questions, I create short videos so that they can just see how I worked it out. So let me go ahead and share this one with you. I'm going to copy it and I'm put it here for you all. The first 2 minutes of the video goes over the Webassign tools, so you can just skip to, like, I think the time is 3:50, and from 3:50 to 5 minutes, I show you how to use the graphing tool there. Okay, and so again, in this YouTube channel, you'll see several examples for each section, so you're free to go through them if you want to. But if you send me an email, I will send you this presentation. That way you can go through the rest of the slides. But also in the chat, I saw some of our staff here have been putting links. So we also have a YouTube channel with all the other recorded links. They're going to put this video in there as well. So if you need to go back and review it, maybe slower, then you'll be able to do that if you copy that link that they posted there. And hopefully everybody has been asked for their student ID. And again, the purpose of the student ID, I'll give you an example for my classes. If my students attend tutoring or if they attend the Friday happy hour, they get a point extra credit. So, and then for some of you, it's part of your grade. If you're in NCBM 0314, for example, if you go to tutoring, then you can also use this as your tutoring hours. But if you don't provide that student ID, then there's no way for us to communicate to your instructor that you attended the session. So if you have any questions, we do have a tutors here that can also answer questions. Um, you can stay and they can ask you. So okay, so there's Miss Anna. Just wait a second, and somebody will ask you for your ID. Okay, so if you have any questions, please feel free to ask them. And I'm gonna stay here for a few minutes, and then we also have our tutors as well.
Thank you, Ms. Chuka, for your presentation. We do want to remind you all about the previously recorded sessions, which are available on a YouTube playlist. This session will also be available on that playlist later today. Also linked is a short survey to help us improve our TVE sessions. Please take a few minutes to fill out that survey and remember to send your student ID number to Ms. Patricia if you haven't yet. There are individual messages to everyone to sign you all in, and your ID numbers will be private between you and Ms. Patricia. Before you all leave, I want to share the TVE session that we will have next Friday. Here we go. So next Friday for 1314, we will be reviewing the standard form of quadratic equations, graphing, synthetic division, and finding zeros. For 1324, they'll be covering factoring, exponential equations, and logarithmic equations. Thank you all for coming in today. We hope you all have a lovely weekend. If you have any questions, please feel free to use the chat box or your mic, and we hope to see everyone again next week. If you haven't given your ID number yet, give us just a second and we'll go ahead and message you individually, okay? Thank you.